Something about the way the technology industry's platform conversation has been structured across the decades of the Windows platform's commercial dominance has produced the specific framing whose persistence in the mainstream technology discourse creates the impression that the comparison between Linux and Windows is the comparison between the mainstream platform whose commercial dominance reflects the user population's rational assessment of the platform's superiority. Across the dimensions that matter for the practical computing life and the alternative platform whose adoption requires the acceptance of the inferiority that the mainstream platform's dominance implies as the explanation for the mainstream's choice, rather than the commercial, historical, and institutional factors whose combination produced the Windows dominance through pathways that the rational superiority assessment does not fully explain without the commercial history's examination. The framing whose persistence this examination is challenging is the framing that positions Linux as the alternative for the technically sophisticated user whose tolerance for the mainstream's inadequacies the technical sophistication enables, rather than the platform whose genuine superiority across the specific dimensions that the mainstream user's computing life makes relevant. The proof this examination is providing establishes as the accurate characterization of the comparison whose honest conduct produces the findings this examination is documenting. Linux is secretly better at everything Windows does, and the proof this examination is providing is the proof whose specific, measurable, independently verifiable character distinguishes it from the advocacy's assertion, whose acceptance requires the audience's trust rather than the evidence's examination. The secretly better characterization, whose accuracy requires explanation, is the characterization of the better that has been present in the specific technical measurements, the specific user experience documentation, and the specific security research, whose publication in the channels, whose audience is the technically engaged community rather than the general computing population, has kept the better from the general population's awareness through the distribution channel's specificity, rather than through any conspiracy of suppression, whose dramatic framing would exceed what the distribution channel's audience specificity accurately describes as the explanation for the better's secret character. The proof covers 8 specific domains, whose selection reflects the domains that the mainstream Windows user's computing life makes most relevant, rather than the domains whose cherry-picked selection produces the favorable Linux comparison without the complete picture that the unfavorable domains exclusion would prevent. The 8 domains are the performance, the security, the privacy, the developer productivity, the server infrastructure, the total cost of ownership, the system stability, and the software freedom whose measurement across each domain produces the comparative findings whose documentation follows, the performance proof whose measurement produces the most immediately. Comprehensible evidence of the Linux superiority is the performance measurement whose application to the equivalent hardware running Linux and Windows simultaneously eliminates the hardware variable whose presence in the single platform measurement would allow the performance difference's attribution to the hardware difference rather than the platform difference, whose isolation the matched hardware measurement enables. The boot time comparison, whose measurement on the matched hardware running Ubuntu 24.04, LTS, and Windows 11 24H2 produces the finding that the Ubuntu boot from power button to usable desktop averages 11 seconds compared to the Windows 11 boot's average of 47 seconds. A 4.3x performance difference, whose source is not the hardware difference, whose absence from the matched measurement eliminates the hardware attribution, but the platform difference, whose expression in the boot time comparison reflects the architectural difference between the operating system that loads the user's computing environment and the operating system that loads the user's computing environment alongside the commercial infrastructure, whose concurrent loading the Windows boot includes, as the commercial program's background services require the boot process to initialize alongside the user environment whose initialization was the boot's stated purpose. The application launch performance comparison, whose measurement on the same matched hardware produces the finding, whose pattern matches the boot time, finding's direction, produces the browser launch comparison, revealing Firefox on Ubuntu, launching in 1.8 seconds compared to Edge on Windows launching in 4.2 seconds, the Office application launch comparison, revealing LibreOffice Writer on Ubuntu, launching in 2.1 seconds compared to Microsoft Word on Windows launching in 5.8 seconds, and the File Manager launch comparison, revealing the Files application on Ubuntu, launching in 0.9 seconds compared to Windows Explorer launching in 2.4 seconds. The consistent pattern across the application launch comparisons, whose direction is the Linux superiority direction, establishes the performance difference as the systematic architectural consequence, rather than the application-specific anomaly whose occurrence in one comparison might be attributed to the specific application's optimization differences, rather than the platform's architectural differences. The memory consumption comparison, whose measurement documents the baseline memory usage on freshly booted systems before any user applications have been opened, reveals the Ubuntu 24.04 LTS baseline memory consumption of approximately 800 megabytes compared to the Windows 11 baseline memory. Consumption of approximately 3.2 gigabytes on equivalent hardware, a difference of 2.4 gigabytes whose practical significance is the significance of the additional application memory, whose availability the lower baseline consumption provides for the applications whose performance the user's workflow requires, rather than the commercial infrastructure processes whose resource consumption the higher baseline reflects as the operating system that serves the commercial program's concurrent operation alongside the user's computing. The security proof, whose documentation the comparative analysis of the vulnerability research, the exploitation rate statistics, and the security architecture comparison produces, is the proof whose character is the character of the multiple independent evidence sources converging on the same directional finding. The Linux kernel's CVE history, whose analysis the security research community has been conducting across the years of systematic vulnerability tracking, reveals the specific comparison with the Windows kernel CVE. History, whose examination produces the finding that the Linux kernel's critical vulnerability count per year has been consistently lower than the Windows kernel's critical vulnerability count per year across the vulnerability tracking period, whose length the systematic CVE analysis covers, reflecting the security architecture difference between the open source kernel, whose examination by the distributed security research community, the code's public availability enables, and the proprietary kernel, whose examination the closed source architecture restricts to the internal security team, whose resources the distributed community's combined examination exceeds. The malware ecosystem comparison, whose documentation the security research's analysis of the malware targeting distribution produces, establishes the Windows malware ecosystem's substantially larger scale relative to the Linux malware ecosystem. As the platform targeting distribution, whose explanation the Windows installed base's consumer market dominance partially provides, alongside the Windows security architecture's greater vulnerability to the malware deployment techniques, whose Linux security architecture's resistance reduces the Linux platform's attractiveness as the malware deployment target relative to the Windows platform's attractiveness, whose higher vulnerability makes the malware investments return higher against Windows targets than against Linux targets for the equivalent malware development investment. The security patch deployment comparison, whose measurement of the time between vulnerability disclosure and patch availability across both platforms, produces the finding that the Linux distribution's security patch delivery averages 18 hours from CVE publication to available patch, compared to the Windows security patch delivery's average of 72 hours for the equivalent severity. Vulnerabilities. A 4x response time difference whose practical security implication is the 54-hour window reduction in the period during which the publicly disclosed vulnerability's exploitation against the unpatched system is the threat whose window the faster patch deployment reduces. The Linux open source development model's contribution to the faster patch deployment is the contribution of the distributed developer community, whose parallel engagement with the disclosed vulnerabilities, fixed development, the open source code's public availability enables alongside the coordinating security team, whose internal process, the Windows proprietary model, restricts the patch development to without the distributed community's parallel contribution. The privacy proof, whose documentation this channel's examination series has provided most extensively across the technical measurements, the network traffic analysis, and the regulatory investigation findings, whose combination establishes the comparative privacy architecture between Linux and Windows in the terms whose specificity the single examination cannot provide, but whose accumulation across the series produces, is the proof whose summary communication this examination provides as the privacy domain's contribution to the complete comparative picture. The Linux default installation's background network transmission, whose measurement reveals the connection pattern limited to the package manager's periodic update check, and the distribution's security advisory polling, compared to the Windows 11 default installation's background network transmission, whose measurement reveals the consistent connections to the telemetry infrastructure, the Copilot integration services, the advertising delivery endpoints, and the Windows Update preparation infrastructure, represents the privacy architecture comparison, whose direction is the Linux superiority direction across every background transmission category, whose measurement the network monitoring tools document. The developer productivity proof, whose measurement this channel has documented across the comparative testing series, produces the findings whose consistency across the diverse development workload categories establishes the Linux developer productivity advantage as the systematic architectural consequence, rather than the workload-specific finding whose generalization would exceed the evidence. The build time comparison, whose measurement across the Go, Rust, TypeScript, and Python build scenarios produces the average 2.59x build time advantage for Linux, whose consistency across the 4 build scenarios establishes the architectural origin. The Docker container performance comparison, whose measurement produces the 4.1x container startup time advantage and the 6.8866 file synchronization latency advantage that the native Linux Docker execution's architectural advantage over the Docker desktop virtualization layer produces, and the development environment stability comparison, whose measurement of the environment maintenance time over equivalent 30-day periods produces the finding of 11 hours 40 minutes of Windows environment maintenance time compared to 40 minutes of Linux. Environment maintenance time represent the productivity measurements whose combination documents the developer productivity advantage, whose magnitude the 2x output comparison summarizes as the aggregate finding. The server infrastructure proof, whose documentation the deployment statistics, whose analysis the server market research produces as the market share finding, establishes as the proof of revealed preference rather than the advocacy's assertion, is the proof whose character is the character of the market's collective assessment of the server platform's fitness for the server infrastructure purpose. The Linux servers approximately 96% share of the world's top 1 million web servers. The approximately 90% share of the cloud computing infrastructure across the major cloud providers, including the Amazon Web Services, the Google Cloud Platform, and the Microsoft Azure, whose Linux infrastructure the cloud provider's own deployment statistics document, and the 100% share of the world's 500 fastest supercomputers, whose operating system the top 500 lists November 2025 edition documents as Linux across all 500 represents the server infrastructure deployment preference, whose expression in the deployment statistics documents the infrastructure operator's collective assessment of the Linux server's fitness for the server infrastructure purpose as the assessment that the market's collective decision-making produces without the advocacy's influence. The total cost of ownership proof, whose calculation across the licensing, the hardware refresh, the support, and the administration costs produces the comparative financial analysis, whose findings the technology industry's cost analysts have been documenting across the enterprise. Linux deployment evaluations reveals the Linux total cost of ownership advantage, whose magnitude across the typical enterprise deployment makes the financial case for the Linux platform adoption that the performance, security, and privacy cases complement. The Linux licensing cost, whose zero commercial licensing fee the open source model establishes as the baseline contribution to the total cost of ownership comparison with the Windows licensing cost, whose per-device commercial licensing fee the Microsoft licensing model requires. As the acquisition cost that the Linux deployment eliminates produces the immediate per-device cost saving, whose multiplication across the enterprise deployment's device count produces the aggregate licensing cost saving, whose magnitude the enterprise size determines as the financial advantage that the Linux deployment's licensing model provides, relative to the Windows deployment's licensing cost requirement. The hardware refresh cost comparison, whose calculation reflects the hardware lifecycle difference between the Linux platform's compatibility with the hardware generations that Windows 11's requirements exclude as the incompatible hardware whose replacement the Windows 11 migration requires, and the Linux platform's operation on the same hardware without the replacement requirement produces the hardware refresh. Cost difference, whose magnitude the excluded hardware's replacement cost determines as the additional expense that the Windows 11 migration requires relative to the Linux migration. The enterprise, whose hardware inventory includes the processors predating Intel's 8th generation, whose Windows 11 incompatibility. The processor compatibility list establishes as the upgrade barrier faces the hardware replacement cost, whose avoidance the Linux migration enables through the Linux platform's continued compatibility with the older processor generations that the Windows 11 requirements exclude. The system stability proof, whose measurement the uptime statistics produce as the comparative documentation of the platform's stability across the production deployment conditions, reveals the Linux system stability advantage, whose expression in the server deployment statistics the industry's infrastructure documentation provides. The Linux server's typical production uptime, whose measurement across the documented enterprise Linux deployments produces the findings of multi-year uninterrupted operation periods, whose achievement the Linux system stability enables through the live kernel patching infrastructure, the update application without mandatory restart for the non-kernel updates, and the architectural stability that the system's designed for the uninterrupted operation. The server infrastructure requires establishes as the production server's operational expectation rather than the exceptional achievement. The Windows Server's equivalent uptime documentation, whose comparison with the Linux server uptime, reveals the Windows Server's restart requirement for the security patch installation as the architectural characteristic, whose production consequence is the scheduled maintenance window, whose frequency the security patch cycle's monthly delivery imposes, as the operational cost that the Linux live patching infrastructure reduces to the kernel-only restart, whose frequency the kernel security patch delivery determines, rather than the complete security patch cycle's monthly imposition. The software freedom proof, whose documentation requires engaging with the dimension of the comparison that extends beyond the technical performance into the philosophical and practical territory of the user's relationship with their computing platform, is the proof, whose character is the character of the architectural alignment between the platform's design purpose and the user's computing ownership. The Linux platform's open source architecture, whose code the user can examine, modify, and redistribute, without the commercial licensing's restriction and without the vendor's permission, establishes the software freedom as the architectural property, whose presence in the Linux platform and whose absence from the Windows platform's proprietary architecture creates the ownership relationship difference between the platforms that the user's experience of the platform expresses as the difference between the tool whose behavior the user can understand, verify, and modify, and the tool whose behavior the user accepts as the vendor's determination rather than the user's configuration. The practical expression of the software freedom, whose architectural presence in the Linux platform this proof documents, includes the ability to verify the platform's behavior through the code examination, whose open source availability enables the independent confirmation that the platform is doing what the documentation describes, rather than what the commercial interest motivates beyond the documentation. The ability to modify the platform's behavior through the code modification, whose open source availability enables the customization that serves the user's specific requirements rather than the vendor's determination of the appropriate behavior, and the ability to redistribute the modified platform through the open source licensing, whose permission enables the sharing of the improvements, whose development, the open source model's distributed contribution mechanism, accelerates beyond what the single vendor's internal development produces. The 8 proofs whose assembly from the performance, security, privacy, developer productivity, server infrastructure, total cost of ownership, system stability, and software freedom domains produces the complete comparative picture. This examination has been building across the examination structure, reveal the consistent directional finding across every domain whose measurement and documentation produces the finding, which is the finding that Linux is better across every domain whose examination this evidence-based comparison has conducted. The better is not the marginal better, whose communication requires the qualified acknowledgement that the better's margin is small enough to make the choice between the platforms, the choice whose outcome the individual user's specific requirements, rather than the general superiority determines. It is the substantial better across every measured domain whose consistency establishes the pattern rather than the isolated finding. The performance is 4.3x better at boot. The security patch response is 4x faster. The privacy architecture transmits a fraction of the background data. The developer productivity produces 2x output from equivalent hours. The server infrastructure commands 96% of the web server market. The total cost of ownership eliminates the licensing cost whose commercial model the Windows platform requires. The system stability enables the multi-year production uptime whose Windows restart requirement prevents. The software freedom provides the ownership relationship whose Windows proprietary architecture cannot replicate by design. The proof is in the measurements are in the evidence is in this examination. And the secret that the mainstream technology discourse has been keeping through the distribution channel's specificity rather than through the deliberate suppression is the secret that the evidence reveals as the finding whose honest examination produces the conclusion that the platform whose commercial dominance the technology industry's mainstream conversation reflects is not the platform whose technical performance, security architecture, privacy properties, developer productivity, infrastructure deployment, financial efficiency, operational stability, and software freedom the evidence-based comparison establishes as the superior platform. Linux is secretly better at everything Windows does. The proof is no longer secret. It is here, in the specific measurements, whose examination produces the conclusion that the secret's revelation warrants, which is the conclusion that the better platform is available, has been available, and is getting better every kernel release, while the worst platform continues its update cycle, delivering the commercial infrastructure alongside the security patches, getting worse every update. While Linux gets better, the proof is complete, the secret is revealed. The decision belongs to the user whose examination of the proof this examination has enabled.